Hey, common scientists. We are coming to you this week with an episode I am so excited about because we're talking about water. It's like the building blocks of most life that's necessary on the planet. It makes up a huge percentage of you, and it also makes up a big percentage of some potential problems that our society and world might be facing, but we'll get to that later. So I am just ecstatic to be talking to you about water, H2O, the thing that is flowing through all living things. Outside of that, I just want to give a little reminder. We are common scientists on the Common Science Cast, and that means that we do research, we bring it to the table, and we engage in common science, meaning none of us are experts, and that's okay. That's the whole point here at Common Science, is to come together, ask questions, and use the scientific method. And today we're going to do that surrounding the topic of water. So I'm going to kick it off with a question, which I usually do. And I'm going to kick it to Aidan, and I'm curious, Aidan, how much water you drink on a daily basis, and if that is achieving your goal, if you're of your ideal self drinking water.
So I do not have a goal of how much water I should drink.
Really?
Yeah. So for our listeners, I do not have a goal of how much water I should drink in a day. I I suppose I have a goal to drink one water bottle before having any coffee or other liquids. But besides that, I just drink when I'm thirsty, and we'll try to drink a good amount when I'm thirsty.
Trey?
Problem with that is sometimes it can be difficult to tell when you're thirsty. Like once your mouth is dry and you're like, doing all that stuff and feeling like the effects, it's like you might have been thirsty for an hour already. I don't know. But I probably drink maybe half a gallon to a gallon. I definitely feel a lot better when I'm drinking at least a half a gallon. I can tell when I haven't had enough water. I'm tired, headaches and stuff like that. Sometimes it's like, oh, like, am I hungry? Am I tired? It's like, no, I'm just dehydrated. Big fan of drinking plenty of water. I think my biggest issue with it is not how much I'm drinking, but it's like I need to get better at spreading it out because there's just long periods at work when I'm not doing it or whatnot. And then, so there's like an 8 hour period where it's like, oh, you're pretty dehydrated, my guy. You were super hydrated before and after, but so that's what I gotta get better at. How about yourself?
Yeah, that's tough. I drink between 4 and 5 liters of water every day. My goal is to hit 4 liters, but
So 4 liters to half a gallon, which is more? Or what did you say, Dre?
is it half a gallon to a gallon?
Half a gallon to a gallon, and you're 4 to 5 liters.
Mm-hmm.
Okay, while you're continuing to talk, I'm gonna do some conversion here quick.
Okay, I think I drink more, but yeah, you should convert it so that you can tell them all, either in gallons or in liters, how much that is. Needless to say, it's a good amount of water, and it's actually quite a bit more than what's recommended for women according to Mayo Clinic. So it's recommended that women drink 2.7 liters, and I think men it's 3.6 liters. I'll double check that and we'll link it in the cast notes. However, that's for an average woman who's not doing any exercise. And so if you're doing any exercise and partaking in any activities where you might sweat, or you're eating a lot of salty foods, or you're drinking a lot of liquids with high sugar, all of that will increase the amount of water intake that someone should have. So I'm a pretty active individual. I try to get about an hour of exercise a day, whether it's just like a vigorous hike or like an actual weightlifting exercise. That varies some, but
Right.
that increases my desire to drink water some. So let's inflate it, go from 2.7 liters to 3.7 liters, okay? And then the last bit is because I also struggle with something called interstitial cystitis, and it's not been a confirmed diagnosis. However, it's a rule-out diagnosis, so like the last diagnostic test that I could go in for would involve catheterization, which is where a small tube is inserted up the urethra, and they would like flush in a chemical that would either cause me extreme pain or comfort. And like I think one or the other version is like, oh yeah, you have it, but it's like a 50% chance that it would be extreme discomfort. And the urologist I worked with was like, oh, like it's probably not worth it because there's only one. Anyways, long story short, they said that the more water I would drink, the more it would encourage the lining of my bladder to have more normal behavior. So interstitial cystitis is like a fancy way of saying that the inside lining of my bladder gets kind of crumpled up. So the bladder has a couple layers of tissue. So the inside lining of the layer of tissue in my body just decided to be kind of funky. And so additionally for me, flushing water through my system is really important. And so like that is what makes me try to reach closer to 4 liters of water a day.
So for our listeners, 4 liters is about 1.06 gallons. So it's a good amount of water.
Yeah. So I'm pretty religious about it. In case you're a listener who's wanting to increase your water intake, I'm the one who got Aidan onto the idea that before you have any other liquids in the morning, you should drink like a full liter of water. Which for us is a full water bottle. We have pretty big water bottles. That's a really great first step, is trying to get yourself to have like one, whatever it is for you, a glass, a water bottle before you have any coffee. And then I don't include my coffee intake usually as a liquid intake, although Mayo Clinic says any liquids can count. I just personally don't count them. And then I'll try to do another one by 11 a.m., another one by 2 p.m., and then my last one around 4 p.m. so that I don't have to get up during the night to use the bathroom. But I'm very regimented.
Yeah.
Now you all know about my health routine associated with water.
I really like that this is kind of, and maybe it is just recent, maybe it's just I'm seeing it recently, but it's kind of becoming a thing now, because and I see a lot of people with those water bottles that just telling you how much you need to drink by this amount of time. I think it's super cool because it's obviously something we all know, and I think we have an idea that we should be drinking a little bit less water than we should, for most of us, but in general we all know more water better. And you can do any quick Google search and be like, oh, water is going to help you with headaches, with fatigue, with hunger, with this, blah, blah, blah. Like so many ailments that we specifically as Americans have, weight loss, irritability, like so much energy, like all these things. But at the same time, like part of being a comma scientist, part of what we're trying to do is not just know the stuff, but actually act on it. Like take out certain variables in your day where it's like maybe it's weight loss, maybe it's fatigue, maybe it's irritability in the morning, energy, whatever. Take something out and then insert the water, right? To see, is the water the actual, or actually don't take anything out, just add the water to see if this fixes it. And then you can see like relatively scientifically, right? Record the data, and then if you feel better, then just keep doing it, right? But it's like it's something that we all know, but we don't do it, and I'm just like I get so frustrated with everybody in my life that does not drink enough water.
I didn't.
So how frustrated are you guys with me?
Sounds like I'm pretty frustrated.
Yeah, I'm pretty frustrated. I read the whole like Mayo Clinic website though, and it said for a lot. Well, it said for, did it say a lot or some? I don't know. We'll go with some because that feels more moderate. That feels like a more Mayo Clinic-y stance. But that quite a number of people can just drink when they're thirsty, and that ends up being enough. And so, like, not monitoring it might be fine for you. Also, like, you don't seem to have other health issues, so maybe for you, like, it's okay. Mm-hmm. For me, however, and like, you guys cool if we just get a little personal about health here for a minute on the Common Science Cast?
Go ahead.
All right. So, like, I actually would have, if you said no, like, I actually would have stopped telling the story. But, like Dre said, it's just really important to experiment and find what's good for you. And about a year, I did not always drink this much water. About a year and a half ago, actually about 2.5 years ago, I had gained like 15 pounds over a year, 30 more pounds than I weigh now. And my whole entire life had struggled with healthy bowel movements, meaning, and mostly with like regularity. And if you're cringing in your seat, it's okay. Like, I understand you can fast forward 5 minutes, but if you're cringing in your seat, you should be aware that like half of Americans struggle with this issue. Like 50%, a good chunk. It might even be higher than that, and we'll link it in the show notes. But a lot of people struggle with like just digestive issues. And so I struggled with this my whole entire life, like to a clinical degree, where I had to monitor. I had a poop diary all throughout like high school and college to just make sure I was like managing my body. And I was super embarrassed about it. I was really shameful about it. And about a year and a half ago, I guess 2 years ago now, my older sister, I visited her overnight, and I always knew like I should drink more water. I should drink more water. I drank almost no water. All the water that I got during my day was pretty much through food. That's it. So nearly no liquids. And my older sister was like, "Oh my gosh, I drink this whole liter before I go to nursing school. I can't even imagine. Like, I think I'd pass out if I didn't drink this whole thing before I left the house." And I was just shocked. I'm like, "God, if she can do that before she leaves the house, I can commit to one water bottle, like 1 liter a day." And like the very next day, I got myself a liter, like a liter sized water bottle, and I made myself drink it over the period of the day. It was really challenging. I had to go to the bathroom like every 20 minutes to urinate, and I was uncomfortable for like a week. After about 2 weeks, I worked my way up to like 2 liters, and have had since like continued increasing it. But after about 4 weeks of increasing my water intake, I realized that this bowel movement problem that it had for my whole entire life, that even clinicians said that it was a problem. Like, one clinician said my bowels didn't, or my intestines didn't do peristalsis normally. Another clinician was going to prescribe like a daily medication. Like, a serious problem my whole life was gone. Like, gone. And to this day, I have not had to like keep a journal. I have had relatively like normal digestion. I've lost 30 pounds since like the 2.5 year ago mark. I've also done other things to help with some weight loss because I just wanted to feel more healthy. But like, increasing my water intake was life changing. Because I did just that. I was like, okay, what does this look like? How can I improve this? Do I feel better? And then I did, and then I just kept feeling better and better and better. And now, like 2.5 years later, I've lost 30 pounds, and I feel just so much better throughout my day because I'm not carrying around just like crap. Literally and
Wow.
figuratively. But like,
So three
yeah.
things. I had no idea this cast was gonna go this direction. But number two,
Number two, he says.
So the number two is that
Come on.
I had no idea how prevalent this was. And so this survey on PubMed, it seems like there's some conflicting results, but it seems like a decent number of sources say that. I mean, it's like 40% upwards to like 70%, but this specific survey says that 2/3 of their respondents suffer with, let's see here, were burdened by like GI symptoms, including like diarrhea, like being backed up, all these other challenges. Yeah, I had no freaking clue, but it's common.
I've told you, it's super prevalent, and everyone's so ashamed to talk about it, myself included.
Digestive disease account for over 100 million ambulatory care visits annually in the U.S., yet comparatively less is known about the true burden of GI symptoms in the general U.S. population.
Yeah.
I mean, yeah, it's hard to measure. People don't talk about it.
Right. And absolutely, common scientists, I mean, we are in no way claiming to have like health advice for you and whatever you're dealing with. Talk to your clinician, talk to your doctor, do what you need to do. But I do think, like, in a world where talking about these sorts of issues is so shame filled, um, we miss out on hearing from a friend about something like this. And I hope that in me sharing this experience, that's maybe a little too candid for some of you, like, for the others of you who maybe are struggling with something, you can hopefully learn just like a tidbit or two and might feel better. I can't tell you how better I feel having made that change and prioritized water and just said to myself, like, nope, this is non-negotiable. Like, I am deciding today, this is non-negotiable. This is my health we're talking about, that I'm going to do better at this. And like you said, Dre, earlier, everyone knows we talk about it. You should drink more water. We should drink water. And we just don't make it a priority. But for me, making it a priority was life changing, actually.
That's amazing. Yeah. So the third thing I was going to bring up is that it is amazing how there are little tweaks that can have a profound impact on a person's life. I'm trying to remember. I'll have to try to look it up, and no promises, common scientist. But there's a documentary series that was or is focused on rare diseases, which means that it impacts fewer than 200,000 people each year in the U.S., and that those sorts of diseases have their own challenges, one of which being that there's not, for any specific disease under that classification, there might not be very many experts or very many patients nearby that you can learn from. And the premise, so actually now that it's starting to come back to me as I talk about it, anyways, long story short, there was one episode where there was a young woman who, I think she stopped eating red meat, or it was one simple like nutritional, or she started taking a supplement of iron. I Yeah, it was a single tweak in to her diet, and this excruciating pain that had been caused by some genetic disorder just evaporated overnight. And it was this disease that took, I mean, 7 years for a diagnosis. So she had been going to all these different doctors. Nobody knew what was going wrong with her. And it was just this one tweak to her diet that completely transformed her life. So, I mean, but obviously that's an exceptional case. I think water for anyone is, and would improve their lives. And you guys are inspiring me. And now I'm feeling like I'll have the Dre on my right shoulder and the Lauren on my left shoulder when I'm not drinking enough water, and I need to start measuring it more and just being more conscious of it. But yeah.
Who knows what levels you might unlock? Hydrated 80 might be a whole nother beast.
Yeah, actually, though. So, what is water? What makes up water?
H2O.
Yes, H2O, and
Yes.
lots of other things that we like to add to our water, to our drinking water. But the molecule water, H2O, as I'm sure you've commonly heard it referred to, actually refers to its elemental makeup. So I'm curious, Aidan, would you be willing to describe to our listeners and viewers what an element is?
So an element is a type, an element is a like category of different fundamental materials, and you can have atoms of that, and an atom is like the smallest, or so we thought, indivisible unit, like a unit that cannot be divided or split, which obviously, I mean, nuclear bombs kind of changed that perspective. But atoms are these super small like you can think of them as little dots, and they have some mass. They have some properties that are characteristic of them, and each of these elements have their own set of unique properties. So hydrogen has a mass of, I think, around 1 AMU, which is an atomic mass unit, and it's got, is it one? And it's got one proton. This is where I'm getting a little fuzzy on my
Yeah, I
chemistry.
wasn't
And
planning on going that
okay,
that
but
far into depth, but what I wanted to help people just contextualize is that there are these basic building blocks that everything is made up of. And those are elements. And at their core, they're like the most simple, most broken down piece of substance. And for every broken down piece of substance, you can classify it and you can name it and put it on this nice little chart that gives you a ton of useful information to determine like what role that little piece might play in what makes up life and what makes up biodiversity. And for water, H2O, as you commonly hear it, literally H, 2, and O refer to its elemental makeup, which is super cool. When the first time I learned this, I just remember thinking like, I mean, wow, this thing that I referred to my whole life was actually also telling me the elemental makeup of water. H, hydrogen. 2, there are 2 hydrogens to water's makeup. O, oxygen. And there's ways, so I mean, too much science that I should probably not go into all of it, but the coolest thing about water is that it makes up a huge percentage of our bodies, and it is largely the reason that we're able to have and consume and create energy, because hydrogen is so small and so transferable that you can like trade it around all over in the body to create an energy currency for the body. So the best analogy I ever heard was like, if you go to like a state fair or somewhere where like there's a lot of tents and things and you want to spend a little money at all these different places to get everything you want, you don't want to carry around hundreds, right? You can't have like the $100 bill and be that person. You got to have a bunch of ones, right? Maybe not the state fair. I feel like everything there costs $10. But anywhere else, maybe like, yeah, you want a lot of $1 bills. And hydrogen is similar in that way, where it's small enough that it's easily tradable all over the body and is responsible for like pretty much everything, right? By just shuffling around this one hydrogen. So little did you know, and maybe some of you knew, but like all this time we've been talking about H2O, you actually have knowledge of like this energy currency of your whole body, right? The H in that H2O is responsible for everything that you do from morning till evening. And I think that is so, so fascinating and makes me so excited about water.
That is really fascinating. Thank you for that little lesson, because I did not research that in preparation for that, and I'm just like, obviously, I took college chem and all that good stuff, and I understand the basics of it, but it is, I like the that's I'm not gonna say that's poetic. It was very scientific, but I do kind of like the poetry of water and how important it has been to us on a macro level. Like we all understand, like, oh, like most cities are by water and this and that, and drink this much per day for our digestive system. But it's like all the way down to who we are at the very, very fiber of our being.
Yeah.
It's like it's all about the H2O.
It is. It is.
Yeah.
Specifically about the H.
So,
And then the 2 and the
that was also important.
Yeah.
But yeah, I mean, like you said, Dre, it's to extrapolate from what you were talking about how water is just, I mean, so deeply personal to our cultures, and then down to the individual level, like because is so necessary to our existence. It flows through our veins and yeah, makes us into who we are. Uh, Lauren and I went to the Bell Museum, which is the Bell Museum of Natural History that the University of Minnesota hosts, and we went to it over the weekend. And
in St. Paul, Minnesota.
In St. Paul, Minnesota is where it's located, and we went to it over the weekend. And one of the factoids that I came away from it with was the Goldilocks paradigm, which is that Earth is so unique in creating life because it's in the just right place where it's far enough from the sun that it's not so hot that all the water would evaporate, and it's not so far that all the water would be so cold that the water can't do anything. It's locked up, and it's in this Goldilocks zone where the water can do its thing, flow through our bodies, flow through our rivers. Yeah, so it's cool to take it from the individual to the society to the planetary. But yeah, it is, yeah, definitely. Like you said, Trey, not the science, maybe not poetic, but I mean, thinking about it from the poetic perspective is just profound for sure.
Yeah, I know we have a lot more science to get to, but keeping on and not that Goldilocks zone isn't, but just a little bit more of pondering. Do you guys think that we could find life in the universe apart from water, apart from hydrogen and carbon, perhaps too as well?
I'm fascinated with the idea of a more like silicon-based life form, and I think I've heard that thrown around. And I think it is more probable that there is life than there is not life, whether or not it's based on hydrogen, like moving around, more based on hydrogen moving around or not. I don't know. I would say it's more statistically likely that it is based on hydrogen just because of the process of like a star exploding being being or providing a more likely scenario for hydrogen and like smaller elements to travel further because they're just lighter. So yeah, I guess that's my basic understanding. I'm not like an astrophysicist or a life on other planets specialist. I'm just a common scientist, but that would be my.
Yeah, I'm not sure about the. I'm not sure about the star exploding piece, but I think if I remember correctly, with the Big Bang, so when the universe was created, there were quarks and all these different weird sounding particles that then fused together to make hydrogen, and then like the other elements kind of built up from there.
Mm-hmm.
And like hydrogen being such a building block, I think the $1 bill analogy makes a ton of sense. Where it's like,
it's a good
because it's just I mean, I think about like lithium. So like if you're talking about, I mean, if you're talking about a silicon based life form, and we're talking about like robots, right? That perhaps humans created and maybe passed the torch to, if they're run off of batteries,
mm-hmm.
lithium batteries, at least, I think from my understanding, also operate off of hydrogen being passed around.
Yeah.
So, yeah, I mean, I think that.
I think it would probably play a role.
Right.
Either way. Yeah. Yeah, it's a fascinating question. I mean, it's super likely, though, that water is involved, especially knowing you must have missed this at the Bell Museum because that's where this information is also coming from, the stars exploding. But that's how, like, when I think about there being life out there, I think about infinite interactions. And so far as we know, we live in a universe that's always expanding, meaning that there are going to be infinite interactions over time. And interactions in space happen by things running into things. And then big interactions happen when stars explode. And that's what spreads elements around, right? And so in an ever expanding universe, there will be ever exploding stars, which will be always mixing elements. And so I think it's unreasonable to say, no, I don't think there will ever be another perfect mixture of elements that could create life. I think it would be more probable to say, like, yeah, I'm sure there's gotta exist out there that perfect mix of elements that created and allowed for life. I just don't know if we'll ever find it. I hope so, but I'm not sure.
Yeah, I think so. When it comes to life, what you're talking about, the mixture of the elements, I think where a different mixture might arise is in the formation of whatever, like, another being's version of DNA would be. Like, I think that there would still be this, like, I mean, if we're in the same universe and still operating with the same atoms and elements, molecules, I think that whatever mixture of those were to then form the kind of instruction manual, if you will, for that being, I think that instruction manual could feasibly be some different makeup. But anyways, yeah, that's a fascinating question.
Yeah. All of it, though, would likely involve water and hydrogen for sure. Maybe not water, but probably hydrogen for sure. She says as a common scientist.
We're also
with no
common
background
scientists
in-
and not
Extraterrestrial,
astrobiologists. So
Yeah.
yeah.
If you get a chance to check out the Bell Museum, I would highly recommend it if you're in Minnesota or if you're ever visiting.
Or your local natural history museum
Mm-hmm.
or science museum, because science is
king.
it's for everyone.
That's big facts.
So true. So true. Yeah, so just to dive back into a little bit more about hydrogen and this trading that goes on. There is one specific aspect of that hydrogen currency and trading I would love to highlight, and that is the proton motive force. So if you've taken biology, if you're from the state of Minnesota, you should have taken biology in high school. And you maybe don't remember anything, but you might remember this because I think usually instructors beat the dead horse on it. And it is that mitochondria is
the powerhouse of the cell.
The powerhouse of the cell, yes. And within our mitochondria, there's actually a bunch of that hydrogen exchange happening. And the most significant piece of this hydrogen exchange is called the proton motive force. And it's this cute little supply chain that shuffles hydrogens along and banks them up until they can trade in the hydrogens for ATP, which are like carrying around the hundos, the $100 bills, if you will. And that's actually how we also are able to trade in and spend higher energy in the body. And I think often when people think of mitochondria, think of biology, and that's the one thing they might know. They're like, oh, mitochondria, the powerhouse of the cell. They don't know that it's involving water. Then they don't really maybe know that it's involving hydrogen or protons, which is just a fancy word for a positive particle like hydrogen. So needless to say, you can maybe tack on one additional tidbit to your high school biology schema and remembrances. So you've got mitochondria, powerhouse of the cell, and now you know that the powerhouse, the power, comes from the proton motive force, which uses hydrogen, shuffles them along, stores them up, trades them in for ATP. Super cool.
Yeah, that's super cool. It's super cool too to see. I mean, we're gonna get more into water and society, uh, but it's super fun to me to look at the parallels across these different levels of complexity. So there's the in the mitochondria, like you're saying, storing up for the uh, proton motive force, uh, and then cashing them in. I mean, yeah, we get. I mean, we talked in the billionaires cast about saving up our money and investing it.
Mm-hmm.
You can save up your money and buy a car, right? It's kind of a, I mean, just a similar like phenomena that
The body does
yeah, the
well.
body does well, right?
Yeah. Yeah.
Um,
Okay, one more body thing, and then I'll stop. We can talk about society. But there is just, yeah, okay. The cool, I can't say the coolest because I think I already said that 3 times. But another super cool thing is that all of these interactions, all of this trading of hydrogen also happens in liquid, right? Since our whole body is pretty much, well, lots of our body is aqueous, which means liquidy. And um, because of that, there's also this unique interaction of like polarity. And I think the best way to understand polarity, which you can have characteristics, you can be more polar or more nonpolar, is to think of water and oil. And because of the way that water and oil might separate and interact, and you can do a whole bunch of other things with polar versus nonpolar, you have these beautiful cascades of interaction and complexity that also facilitates every organ system, every interaction, even the proton motive force. So, I mean, water, hydrogen, these interactions really, truly, I can't stress enough, are the reason that you can do, I mean, everything that you do in your day to day basis. So, you're responsible for every organ system. And so I hope maybe next time you're in the kitchen you can think about that too. If you're trying to mix up some lemon juice and olive oil for a dressing or something, like you can think about that interaction and that tension at play. And I think maybe even this tension we can parallel then to some tensions in society, but there is tension at play always in the body. But because of that tension, your body is able to do extraordinary things and to balance extraordinary things. Okay, now I'm done.
Wow. Dropping some great science knowledge on us. I love it. I love it. Is before we get off of hydrogens,
Yeah.
or hydrogen, whatever, is the reason why hydrogen is so like pervasive in life and in interactions. So it's on, I don't know if it is a halogen, but it's on like that side, right? Where these far right gases or whatever they are, these elements, they're really readily, like they're really reactive, right? They're ready to change, correct?
So you have them flipped, but you're really close and you're on the right path. So on the right side, you have your noble gases.
Noble gases, okay.
They're noble and steady and stately, and they don't want to interact because they're perfect, right? This other side, though, is much more reactive, much more ready to interact and change and borrow and switch around. And yeah, those elements and like group 1 and group 2 elements you'll see. And if you are a chemistry person, you know what I'm talking about. If you're not a chemistry person, if you picture the periodic table, which is like a glorified rectangle with some spikies on the left side and the right side.
Or you are not driving and you Google it.
Yeah, that too. The left-hand side is the more reactive side, and that's where you'll see your hydrogens. Another one you'll hear a lot about is sodium. That does a lot of cool things.
Yeah.
So, and they're smaller, more reactive, more ready to bump and change. And
Gotcha. And then with it being so reactive, is it because it has one electron, one proton to give? Does that make it more like, is that one of the reasons why it's such a building block? Because when it reacts, it's only exchanging like giving one, right? It's like, it's not like this. It's not like giving 98 or whatever it is, like plutonium or something like dumb stuff like that. It's like, it's all simple. It's all right. Like you said, like, I'm going to give $1. Like, okay, we know what to do with that. Like, we can easily interact with this versus some of these other, I guess, elements, which are.
Yeah, you're exactly right. And rather than like some element with 98, you don't actually ever interact with all those 98. But they're all there, and they're taking up space, and they make it messy and clunky to deal with, and they just make it not good for the body. It's just too much.
What's coming to my mind when you said messy was that pudding model. You guys remember that?
No.
What? The pudding model in chemistry?
No, I don't.
Oh, okay. You guys must have been. You guys are younger than me, so you guys must have got some fancy new way of thinking about it. Never mind that. All right, moving on to society. Whoa.
Oh man, common scientists, our light just went out.
Did it unplug? Do the common science check over there.
The strip is plugged in.
Well, we'll talk about society in the dark, I guess, because
it. I mean,
unfortunately, the outlook's not great.
There it is. Oh. Let's go. We're back.
And there is hope.
Yeah, there's hope. Let there be light. Ye of little faith. So the reason, of course, why the lighting matters is because of the recording for YouTube, not necessarily for the audio. So for you audio listeners, you're probably like, what are these? Why are you wasting our time talking about lighting? Like, our bad. All right. Back to agua. So as many of you guys know, most of the major cities in the world are on a body of water, oftentimes a river, which supplies not only water and food, but also transportation. And there's a whole other things that you can divert rivers and do this and do that for agriculture. The way rivers, like still water, can be a little bit less healthy. So moving water, rivers.
Still water, not still water.
Still water as well. Still water, Minnesota, also very unhealthy. But they do have the St. Croix, so I don't know. All right. So that's all good stuff. Now, according to... Wait, do you guys want to get into water wars yet? Or you guys want to...
Yeah, let's go there.
All right, we're going water wars. All right, so according to the Pacific... No, let me look it up. I want to be specific.
Okay, so why are you finding that? Just to reiterate, mostly for myself. Like, within the context of urbanization, which we've talked about before, cities generally locate near bodies of water, and cities have fallen, right, when water has disappeared. And that's kind of where you're coming in with these water wars.
Correct. And there's some areas in the United States where the water is not looking so good. But according to the Pacific Institute of Oakland, California, there have been 279 cases of conflict over water since, what do you guys think?
1980.
2010.
What?
So,
tell me what is it? What does it mean to be a conflict?
Yeah, that's a good question, Lauren.
Right. So you want me to go back into the study and read it right now? That's what you want me to do? I can. If you guys want to carry on this discussion, I can go into specifics.
No, it's fine. It's fine. We don't have that much time for you.
Are we talking a two-person conflict or? No, just
a political conflict.
We will link it in the show notes.
To be specific, though, conflict does not necessarily have to mean like there didn't have to be blood drawn or like blood shed or anything like that.
Okay. Yeah.
30 people died. Okay.
Right. So, some other kind of quick facts before we really lean into some of the discussions, whether we have solutions, issues, thoughts, whatever, the future of water. So 3% of water is fresh water. 1%, so 1/3 of that, is accessible because so much of our fresh water on Earth is frozen. 1 billion people still lack access to safe water, and over 2.5 billion lack access to adequate sanitation.
Whoa. Okay, numbers. 3%.
Of all water on Earth is fresh water.
We have access to 1%.
1% total, correct.
Holy cow. Has that changed since climate change? Did you see that at all or no?
It looks like, I mean, that's generally the issue, but from what I saw, that was up to date, that it's still about 1%. And
1 billion people still don't have access to water.
Correct.
Wow.
Correct. So while we started off like taking water for granted at the beginning of the podcast and, you know, being like, oh yeah, I could just drink more water and get my little fancy water bottle and all that stuff. There's a lot of people living in, I suppose squalor would be a good word, where they don't have clean drinking water. And unfortunately in Flint, Michigan in the US, they also don't have great water either. But that's a conversation for another day. So
oh my gosh. Yes. Also, in Rochester, Minnesota, there was a major problem with cryptosporidium.
Okay, go on.
Okay, so sorry, that just reminded me.
No, go ahead.
Guys, get this. Okay, so this was before my drinking water, like, epiphany and, like, having less problems. I had a lot of problems. And there was a period of time where I all of a sudden went from not being able to consistently go number 2 to going all the time and having mostly watery, like, consistency. Okay, bear with me, common scientists. It got so bad that there was blood presenting in my bowel movements, and a lot of it over the course of 2 days, and I went into the emergency room. And various things were checked out in the emergency room, among them a stool sample, and they came back and they were like, oh, you have cryptosporidium. Cryptosporidium is a parasite that is waterborne and can live in chlorinated treated water for up to 15 days. And when I went...
Chlorinated treated
water for up to 15 days. So it can live, if it gets into a city system, it's a major, major problem. And the ER clinician was like, yeah, I'm surprised that you have this. I thought this was only affecting the low-income communities. Said that to me. And I'm like,
wow.
Bitch, I live in the low-income communities. I'm a college student. Like, okay, so for the next month, so the only way to get rid of it is boiling your water. And there was because Rochester, Minnesota, the med city of the U.S., can't be having a cryptosporidium outbreak. So they're not telling people, hey, you should boil your water, especially not the low-income communities. And so, so here I am with cryptosporidium, and there is no cure, and the treatment is not covered by insurance. It costs like $900 out of pocket. And as a 20-something, you should be fine. You just basically fight it, but you have cholera symptoms, severe watery diarrhea that you cannot control for up to 6 months.
6 months?
So for the next 2 months, after that, I kicked it in about 3 months, but for the next 2 months, I had a standing hall pass that said I could be excused at any point in time to run, and I'm not kidding you, run to the bathroom. Otherwise, I would not make it, because you just do not have control, because there are parasites burrowing in your intestines.
Cryptosporidium sounds like a nightmare.
It was bad. Wow. Thank God, though, it's a microscopic parasite. Common scientists, you can't actually see it. Otherwise, I think I might have just asked them to take me to Jesus, because
that is like one of the worst, like, to look down after going and just being like, and see, like, there worms. Oh my gosh. Oh my gosh, that is
okay. Sorry. So not only Flint, Michigan, but like it can happen. I mean, really anywhere. The only way at least for cryptosporidium is to boil your water, and no one was telling me to boil my water.
That is a remarkable story. Okay.
Sorry. When you said that, I was like, oh my gosh. Okay.
But
And to ease your guys' mind that what was included in those conflicts wasn't just like a, hey, I want some of that water over there.
Mm-hmm.
What the items that were, or the instances that were included were there must have been violence, so an injury or death, a threat or a threat of violence, including verbal threats, military maneuvers, or shows of force.
Oh, wow.
wow,
Okay. So it did have to be something that
So
resembled
water
violence.
conflict. Yeah, pretty serious.
since 2010.
Mm-hmm.
Yeah.
Wow.
So the Colorado River, one of the most important rivers in America, serves about 400 million people in that greater area. Lakes in that area, such as Lake Mead, many of them are running at about 30 to 40% of like their capacity. So they're super low. And Colorado River has been in a 20-year drought. So obviously when people start talking about climate change and water wars, this is the kind of stuff that they're talking about. And I've been to Arizona. I saw that it was a desert, but it's everybody's like living good, right? It's like you don't really see it, hear about it, or you don't even hear about crypto, whatever it was.
Yeah.
It's radio, like you don't hear about these things, but it's like this is the stuff that the scientists are really looking at and trying to solve these issues. And I mean, I don't like when I don't want to get into politics, but just like when people are campaigning, like these are not the issues that are being brought up. And that's a big problem because we're just so often we're just continually pushing things into the future and like kind of putting it on the back burner. And a large part of that is because campaigning is about winning, right? It's not about, but whatever. We don't need to get into politics, but that is kind of one of the reasons why you don't really hear about these things.
But to affirm what you just said, in my own research, right? I do my research with Google and then I do my research with the university libraries. My research with Google was all affirming what I was searching for because I'm super passionate about water in the body and all of these great things. But as soon as I turned to this academic research, I took off the rose-colored glasses, I took off the Google, right? And I just got the raw research from the University of Minnesota libraries. All I could find was on water scarcity and water pollution and water problems. So you're absolutely right. It's a super serious issue that we are not talking about or taking nearly as seriously as we should be.
Yeah. So much of that area, and famously Arizona, they're kind of really close to hitting kind of that tipping point where it's like we don't have any meaningful or feasible access to water, right? It's like they're gonna have to get all of it complete, like shipped in their aquifers are gonna be dried up, Colorado River not giving them any love. They're on the precipice of hitting that, that countdown to day zero, which is obviously terrifying. And I was talking to you guys before the cast that one of the things I heard growing up living in Minnesota, a place with relatively tons of fresh water, was that at some point in the future, there's going to be wars over water and people are going to be flooding, pun intended, to Minnesota. And we're going to become overpopulated and we're going to, just sprout into like one of these major cities around the world. And that idea as a kid really blew my mind. I just could not understand, number one, how we could have so much of our earth could be ocean and we could be struggling for water. But then number two, how humans could like fight over this and kill each other over this. And silly me, and we fought wars over oil and other silly things. And I looked throughout history, it's endless, countless, innumerable wars have been fought over water. Like, and if you add into like transportation and strategy of where things are, it's like the most wars have been fought over water, probably.
Wow.
Yeah, I mean, it just speaks to how essential it is and how, I mean, core it is to being human. Like, I mean, I think, so I remember back in the Boy Scouts, we were, I think, educated that it was like, I can't remember the number of days as far as the other, but anyways, so water, we were told you had 3 days to live without it. And then it was like a month without food, 2 weeks without shelter. But yeah, I mean, 3 days without water. And so, yeah, it's this resource that we need to go out and get of our own accord. And it is so darn essential. So, I mean, it would make sense why
Mhm.
It would be kind of the root cause of a lot of these conflicts, because conflict tends to be, uh, in my eyes, a last resort. But
Yeah, one of the aspects of my research that I would say was a little bit more consoling um, was that there is a ton of water mismanagement and misuse, and I'll explain why that is consoling. The reason that's consoling is if we're mismanaging and misusing like X amount of water, that means that if we stop mismanaging, we would probably be able to, at the very least, combat um, or add years to the time where we think we might be running out. And an example of that I saw was like with planting crops that really aren't meant to grow in certain areas to help keep up with the demand of food production. And for example, like planting corn in Arizona. So corn is a crop that requires quite a bit of water. It also requires like a good amount of pretty decent topsoil in my understanding. I'm not an expert, but I am a farmer's granddaughter who farms corn. And so, for if you plant corn in Arizona, for example, you would need to irrigate your corn, and your irrigation is coming from a reservoir that's probably shared with the city or shared with whatever, because you're not getting it from a nearby lake because you're in Arizona. Like if you have a farm in Arizona, you've no business planting corn, right? So there are many instances where things like this have happened. And I think if there was stronger policy, and specifically federal policy, that helped manage that, I think that we could probably do a lot better. And maybe there would have to be drastic overhaul of some farming practices that exist right now. But I would rather deal with some food moderation and like carefulness at stores and less food waste here in the US for the next 10 years to be able to have water for the next 200 years versus 100 years. And I think that could be a reality if we took it more seriously based on my like 2 articles that I read. But it is still, I mean, a massive overhaul that would be needed and a lot of change to get to a more a better solution.
yeah, I think, like you said, the massive overhaul is a challenge. And one phrase that sticks with me is science marches on one death at a time, and so does society. And I think that one of the best ways to shift the Overton window and get issues such as water into the conversation, and consequently into action that might alleviate some of the problems in the future, is through education. And one idea that I was exposed to on talking to a friend's dad, who is he's a futurist and is now a dean at the University of Wisconsin-Madison, and he had talked about this idea for a class where the class, rather than being focused on separate topics like traditional ones of law, biology, chemistry, they would focus on a place like a river, and they would then look at that river from a legal perspective, an ecological perspective, um, all these different, a geological perspective, and yeah, try to find try to collaboratively come to some sort of management solutions. So in the specific example, he was talking about a river that involved a lot of different stakeholders, farmers and business owners and all these other sorts of people that would need to be coordinated for such overhaul. But I think more people who can navigate those different realms and figure out ways to meet people's needs is super important. But anyways, yeah.
Awesome. I enjoyed listening to both those last points. Those are interesting. I'm glad that you're saying there's a chance, or
Yeah,
saying there's a chance.
fingers crossed.
Yeah, I definitely just on the water, I am worried because of the human condition and because of politics. Nevertheless, I do believe that science is the answer for so many of our qualms, and I do believe that this specific one can definitely be solved with science and some cooperation.
Well, Common Scientists, thank you so much for tuning in this week on water, some of the importance of water in the human body, all the way up to the level of society. At the very least, maybe you'll think next time you're taking your glass of water about how it might play a role in your body and how it also might play a role in all of our futures.
Hey, Common Scientists. Hope you enjoyed the cast. Thanks for investing in Common Science. We hope it brought as much value to you as it did to us.
To learn more, smash the subscribe button and visit our website, commonscientists.com, where you can read our blog, join our email newsletter, and follow us on social media.
Finally, if you like what we have to say, you can absolutely support us on Patreon. We could always use more support. You can navigate there also from our website, commonscientists.com, Common Scientists with an S, so that we can continue cultivating a community of common scientists.